All right, let's talk about the invisible world that's all around us. The code and the connections that basically run our daily lives. We're going to look at everything from the phone you're probably holding right now to the absolutely massive global networks it connects to. And trust me, there are some hidden dangers and some really fascinating stories in there. So let's just dive right.
I mean, think about it. Your phone is basically your key to the entire world, right? It's your bank, it's how you talk to your friends, it's your work, it's everything. Our whole world is in that little device. But have you ever really stopped to think about what doors that same key might be leaving unlocked? Well, it turns out there are entire groups of experts whose whole job is to figure that out. You can almost think of it like a most wanted list, but for software bugs and security holes. And there's one group in particular that's kind of the gold standard for this. And that group is called OWASP. It stands for the Open Web Application Security Project. Basically, they're a huge global nonprofit, a massive community of security experts. You've got people from big tech companies, bug bounty hunters, all sorts of organizations from all over the world, and they're all working together on one thing, making the software we all use every single day a whole lot safer. And this right here, this is kind of their greatest hits list, or maybe their most wanted list. It's the OWASP Mobile Top 10. This is a rundown of the most critical, most dangerous security risks that pop up in mobile apps. And it covers the whole shebang, from how your data is stored to how apps talk to the internet. So, for example, look at M1, improper credential usage. That's a fancy way of saying an app might be storing your password somewhere that's just way too easy to find. Or check out M9, insecure data storage. That's when an app saves your really sensitive info right on your phone, but doesn't bother to lock it up properly with encryption. And here's the kicker. These aren't just, theoretical problems. These are real vulnerabilities that could be hiding inside the apps you use all the time. But see, OWASP doesn't just point fingers and say, that's broken. They actually help developers fix things. They publish these super detailed guides. You've got the MASG and the MASVS, which are basically the rule books for how to build and test apps that are actually secure. It's this huge collaborative project to just lift the entire industry up and make things safer for all of us. Okay, so that's the app on your phone. But let's be real, that app is just one tiny piece of a much, much bigger puzzle. To really get what's going on, we need to zoom way out and look at the giant, interconnected networks that your phone is constantly talking to. So the fancy technical term for this is a distributed system. But honestly, the idea is super simple. It's just a bunch of different computers that are all networked together so they can communicate. The network at your office is a distributed system. The system that runs your city's traffic lights, that's one too. And of course, what's the biggest, most mind-boggling distributed system in the world? Yep, the internet. It is, without a doubt, the largest and most complex thing like this that humanity has ever cobbled together, connecting billions and billions of devices all across the globe. And this is where we get to the fundamental trade-off, right? The two sides of the coin. All this connectivity, it creates incredible value. It lets us do things we couldn't even dream of a few decades ago. But every single one of those connections is also a potential door for an attacker. And that's where all the scary stuff we hear about comes from. The massive data breaches, the ransomware that locks up hospitals, the attacks that can just knock entire websites or services offline. Okay, but what if we took this idea of a distributed system and just cranked it up to 11? What if you could harness the power of literally millions of computers, not just to chat or share files, but to get them all working together like one single, giant, planet-sized brain? Well, that's the core idea behind something called grid computing. It's all about connecting a whole bunch of systems, usually with really fast connections, and getting them to work in perfect sync to solve one single massive problem. We're talking about problems so complex that even the world's most powerful supercomputer would just throw up its hands and give up. And one of the coolest stories about this ever comes from the search for ET. So there's this nonprofit called SETI, and they have this huge problem. They were using radio telescopes to scan the stars, collecting just mountains of data. But they had absolutely zero money for the kind of supercomputers you'd need to actually analyze it all. So what did they do? Their solution was absolutely genius. They created a screensaver that anybody could download for free called SETI at Home. And here's how it worked. Whenever your computer was just sitting there idle, it would download a tiny little chunk of that telescope data, process it, and then send the results back to SETI. Millions of people downloaded it, and just like that, they created one of the biggest grid computers on the planet, all powered by regular people using their home PCs to hunt for aliens. How cool is that? It's just an incredible story of people coming together, but it also raises a big question. What happens when that kind of distributed power gets misused? What's the dark side of trusting millions of random, anonymous computers to all work together on the same team?
Well, it pretty much boils down to two main risks. The first is what we call data integrity. Think back to that SETI project. What if just one of those computers decided to send back fake results, or even just corrupted data by accident? It could completely poison the entire project, sending scientists on a total wild goose chase for years. And then there's the second risk, system misuse. What if somebody figures out how to use all that incredible computing power, not for science, but for their own personal gain?
And believe me, this isn't just some theoretical thing. There was this wild true story about a group of Russian nuclear physicists, right? They had access to this ridiculously powerful mainframe computer that was built to simulate nuclear explosions. Serious stuff. But instead of doing their research, they decided to start using all that power to mine for cryptocurrency. I'm not kidding. They turned a critical tool for national security into their own personal ATM. And as you can probably guess, that did not end well for them. So here's the big takeaway from all this. Security isn't just one single thing you can fix. It's a problem with layers, like an onion. You've got the security of the code that's actually on your phone. That's why we need things like that OSPOP top 10 list. But then you also have the security of the huge global networks that your phone connects to. It's about the trust and integrity of the whole system, from the smallest app to the biggest grid. And really, it all leaves us with a pretty massive question to think about. This world we've built, this completely interconnected world, it gives us incredible, almost magical power. The power to talk to anyone, anywhere, to access all of human knowledge, to even search for life on other planets. But the question is, are we really prepared for all the risks that come along for the ride?